So hello everyone and welcome to the latest interview in our ongoing intelligence series. I'm joined here today by Stefan Schupke, Head of Business Development for Generators, and Dirk Schlesselman, Head of R&D Application Engineering from EMAG eldec. For those that don't know, EMAG are specialists in induction hardening and heating, and I'm looking forward to hearing more about the company and how they're working within the e-mobility industry today. So thank you both for joining me. And to begin, can you both just tell me a little bit about yourselves and your experience in the industry today?
Hello everyone, my name is Stefan Schupke. I'm electrical engineering and I'm with eldec since 2013. And since 2016, I'm responsible for the business development and the sales of generators worldwide.
Hey everyone, my name is Dirk Schlesselman and I'm responsible for the application engineering department at EMAG eldec. To say a few words about myself, I started to deal with induction heating and hardening as a postgraduate student, and I focused on many different applications as well as computer simulation of such processes. And after getting my PhD 6 years ago, I joined eldec, and since 2 years, I'm responsible for all heating and hardening applications at eldec.
Thank you, both of you. So it's a pleasure to have you both here with me. So thanks again for joining me. So to kick off, I think the first question that I have is to ask, what are the applications for induction heating in the production of electrical drives?
So Liam, I think there's almost an infinite number of different applications we can do in this field. To just name a few examples, there is joining, which could be to join a stator in a housing of an electrical drive. There is brazing, which is required wherever electrically conductive connections have to be made. There's also adhesive bonding, for example, for permanent magnets. There is curing and coating, for example, for stator windings of electrical drives. And there are a lot of preheating and reheating applications that are done before or subsequent to other processes. And induction heating is a very good process here because it usually saves time and is more environmental the environmental sustainability is much better than, for example, compared to a fossil-based furnace.
So thank you for that answer, Dirk. And just to be clear, so induction is a long and well-established technology. Due to the fast-changing and developing landscape at the moment, are there any challenges that are being faced when working on electrical drives for battery electric vehicles?
Yes, Liam, you're right. It is a well-established technology, but of course we have to face a lot of new challenges that I think occur everywhere in the industry, but especially in the production of electrical drives for BEVs. So what we can see is that the quality requirements, especially in terms of temperature accuracy and repeatability, as well as the stability of the overall process, they are increasing all the time. So we have to deal with that. Also, usually projects right now have very tight schedules, so we have to be fast. And what we can see oftentimes is that final actual pieces are not available long before the start of production. So we have to find a way to get good processes of induction heating up and running before we actually have parts in our hands. Also, we have to deliver perfectly designed systems to fulfill the requirements in terms of temperature distribution and cycle time, which also is a very big challenge.
So there does seem that there are a variety of challenges that can be faced. So can you tell me just a little bit more about how EMAG solves these challenges or looks to prevent them?
So I think the methods we use to design our systems have to evolve with the requirements that we're facing. And one thing that helps us a lot in recent years is numerical calculation. So we can do simulations of induction heating processes, and it helps us to design systems before we actually have workpieces available. And we can learn a lot about the process, understand it in depth, and we can even solve some problems before they actually occur in reality. So this really helps. Also, we have a lot of experience with such applications and projects, and I think this is the most important thing. And another big part is that we are able to build very high quality induction coils that are the key to a stable process of induction heating.
So as you mentioned earlier, a state-of-the-art production has high requirements in terms of process stability and also the repeatability. Coils for induction heating are made of soft copper. So do these facts contradict each other?
These two facts don't have to contradict each other necessarily. In our case, we are able to have very tight tolerances for our coils. And we even check our coils with a 3D measuring system and compare it to the CAD model. So we can really prove that our coils are within specifications, which is very important. We create reports of the actual dimensions and provide them to the customer. And also we deliver our coils in rugged protective cases. So we can make sure that the coils arrive at the customer in the same state they were shipped. Yes, copper is a soft material, but we have vast experience in designing reinforced coils with a high stiffness. So we can guarantee for the quality of our coils 100%.
So that's actually really interesting. And as far as I'm aware, induction coils are mostly at the moment still manufactured in a manual process. Over the past few years, it's become possible to manufacture coils with an additive or 3D printing process, which I think you've just mentioned briefly. How do you see this recent development and this already having an impact on the industry?
It does have a big impact on the industry already. And we really believe that this technology is a game changer for the production of induction heating coils. And since we believe that we invested in this technology, and to my knowledge, we are the only induction heating company that has a system for 3D printing of copper material in-house. So we believe that we have to have the full process under our control, meaning we do numerical calculations, we do the CAD design like everyone does, but we also can do the additive manufacturing of coils in-house. And as mentioned before, we have comprehensive quality control. So we already deliver a lot of additive manufactured coils to our customers, and the acceptance and the feedback is very good. So the service life of such coils can be much higher than the traditional manufactured coils. There are some advantages that we could mention. It's high repeatability. You almost have no breathing joints, which might be a problem when you think about the dimensional accuracy of such coils. You have a very high stiffness, long service life, and which is the most important thing, you have a lot of degrees of freedom when it comes to the design of such coils, especially when you think about the possibility of internal cooling of additive manufactured coils. So to sum it up, yes, has a very big impact, and this impact will only grow in the next years.
Thank you for answering, and it's good to hear that EMAG are ahead of the curve and already investing deeply into this. And I think in the next set of questions, Stefan, that I'll aim at you, we'll hear a bit more about how you've been working within the industry. So Stefan, can you give me an overview of some specific products that EMAG produces for electric vehicles?
Okay, so beside the services Dirk spoke already about, so EMAG eldec has a range of generator products which will fit perfectly to the needs of our customers in the automotive industry. I would like to highlight two product lines. There's our new Eco line, EEI Square, and our system line. Both are available from 5 kilowatt to 150 kilowatt output power. Both are state-of-the-art technology with our Siemens PLC and common bus interfaces. And both generators are optionally equipped with a bunch of our EQC models, eldec quality control, to reach the Industry 4.0 requirements. So the main difference between these two products, Ecoline, EEI Square, which means EMAG eldec intuitive interface, and the system line is the HMI. The system line has no HMI. These products requires a higher level control, which is optimum for integrators, which we work a lot on with. And the Ecoline EEI Square has a very modern look with an intuitive interface, as modern as a smartphone.
So following on from what we've discussed, and we've touched on this, I think, by showcasing the products that you offer and also the ways that you work. What are the main benefits for a customer if they choose to work with you on a project?
So eldec is well known as an equipment supplier with very high quality standards and long lifetime of our equipments. So our generators are short circuit and open circuit proofed, and our rectifiers are 95% efficient. Beside the generators, we supply induction coils, process support, process simulation, like Dirk explained in detail before. So also we offer small automation units, and for the hardening, we supply complete hardening systems. And so we do have a deep know-how where the customer can be sure that he can get an excellent support from us. And finally, with a worldwide sales and service network from our mother company, EMAG, we are the right partners for the global acting customers.
Are there any recent examples of projects in the e-mobility space that you can share any details of, following on from what we've just been talking about? Are there any success stories or particularly interesting projects?
Yes, there are some success stories. So we mostly work with integrators. That means there are machine building companies who will supply complete assembly lines, for example, for motors or stators, and we deliver the induction heating equipment. So normally including the heating process. And during the last years, we delivered induction processes for parts of almost all European OEMs. I think I would like to refer to a smaller success story. We've done a small non-automated heating unit to one of our customers, the company Electro, where we can show a success story and a video.
Thank you very much for that. And we will have all the supporting material that has been talked about during this interview up alongside this interview on the website when it goes live. So I want to just finish up by saying thank you both again for your time and answering all of my questions today. And I'm excited to see what will come from you and the company in the future. For those of you at home, you'll be able to watch this and other upcoming interviews on the Quimi website or as part of the latest Quimi newsletter, which should be arriving in your inbox on May the 12th. If you'd like to get in touch with Stefan or Dirk to talk through how EMAG eldec can support you in their latest project, you'll be able to find their contact information alongside this interview on the website. So thank you both again for your time, and I hope you have a great afternoon.
Thank you. You too, Liam.
Thank you.